When people think of experimental aviation, they usually imagine sleek prototypes built inside massive factories by teams of highly trained engineers. But the reality couldn't be more different, as many of history's most unusual aircraft began in ordinary garages where builders worked after their day jobs, spending nights and weekends cutting aluminum, shaping fiberglass, welding steel, and solving impossible engineering problems with little more than determination and imagination. Some projects took years, some nearly killed their creators, and some became legends that inspired thousands of home builders around the world. But today's list isn't about military aircraft or billion-dollar aerospace companies. It's about ordinary people who dared to ask one simple question, which is, what if I build my own airplane? And the answers are far stranger than you might expect. So let's begin. Number 10 is the Colomban Cree, the smallest twin-engine airplane ever built, and at first glance it doesn't even look real, as parking it beside a family sedan makes most people assume it's some kind of oversized remote-controlled model, but appearances can be deceiving because the Colomban Cree is one of the most remarkable engineering achievements in the history of home-built aviation. Designed in France during the early 1970s by aeronautical engineer Michel Colomban, the project had one ambitious goal, which was to build the world's smallest practical twin-engine airplane, at a time when twin-engine aircraft were expensive, heavy, and reserved for wealthy owners or commercial operators. Colomban believed there had to be another way, and instead of making airplanes larger and more powerful, he went in exactly the opposite direction with an astonishingly simple solution to make everything smaller, much smaller. The finished airplane had a wingspan of just under 5 meters, or about 16 feet, and weighed less than many modern motorcycles, with an empty weight of only around 78 kilograms, which is lighter than the average adult passenger. Yet despite its tiny size, the Cree wasn't a toy but a fully certified experimental aircraft, capable of cruising at impressive speeds while delivering remarkable fuel efficiency. The secret lay in its brilliant engineering, as, rather than relying on one large engine, Colomban mounted two lightweight engines directly in front of the cockpit, with early versions using compact JPX engines, producing around 15 horsepower each, while many modern builders have installed more reliable engines or even converted the aircraft to electric power. Watching a Cry take off is unforgettable, as the twin engines scream at incredibly high RPM, creating a sound unlike almost any other airplane, and within seconds the tiny machine lifts gracefully into the air, climbing far better than its size would ever suggest. Pilots often describe flying the Cree as wearing an airplane rather than sitting inside one, because the cockpit is so compact that every movement matters with almost no wasted space, as every control, every cable, and every rivet serves a purpose, which is exactly why the aircraft became an icon among home builders, proving that elegant engineering could outperform brute force. Over the decades, hundreds of builders around the world assembled their own Crys from plans, each adding unique modifications like installing larger engines, experimenting with composite materials, or even creating one of the world's first all-electric aerobatic airplanes, demonstrating just how adaptable Colomban's original design truly was. Today, the Cree remains a crowd favorite at air shows, and whenever one appears, spectators gather with cameras in hand, amazed that something barely larger than a go-kart can fly with such confidence, representing one of the purest examples of intelligent home-built aircraft design more than 50 years after its first flight. But as incredible as the Cry is, our next aircraft proves something even more unbelievable regarding what happens if you could build an airplane powered by the same type of engine found on a lawn tractor and still cruise faster than many training aircraft, which is exactly what happened coming up next with the revolutionary Rutan Quickie Q1.
Number 9 is the Rutan Quickie Q1, the airplane that broke every rule, as most airplanes are designed around one simple idea involving a large wing, a tail, a powerful engine, and landing gear tucked neatly underneath. But the Quickie ignored almost every one of those rules. When people first saw it in 1978, many laughed. Some thought it was unfinished and others were convinced it would never leave the ground. But they couldn't have been more wrong, because behind the strange little machine stood one of aviation's greatest innovators, Burt Rutan. long before he became famous for designing the record-breaking Voyager, which flew around the world without refueling or helping launch the first privately funded spacecraft. Rutan was already challenging conventional aviation as he believed airplanes had become unnecessarily expensive, complicated, and inefficient. His dream was simple, which was to create an aircraft that almost anyone could build in a garage that was affordable to own, cheap to operate, and surprisingly fast. And the result became one of the most influential home-built airplanes ever created, known as the Quickie Q1. At first glance, it hardly resembles an airplane at all, as instead of a traditional layout, the Quickie uses a canard configuration where the small wing sits in front of the pilot and the larger wing is mounted behind with no conventional horizontal tail. And even more unusual, the main wheels are attached directly to the wingtips, giving the aircraft a silhouette unlike anything else in the sky that looked futuristic and almost alien. But every unusual feature had a purpose, as the entire airplane was built from lightweight fiberglass and foam composites, making it incredibly light while maintaining impressive structural strength. And back then, this construction method was still considered revolutionary, with many builders having never worked with composite materials before. Building a Quickie meant learning entirely new skills involving hours of carefully shaping foam, laying fiberglass cloth, applying epoxy, and then sanding every surface until it became perfectly smooth, because in an airplane this efficient, even tiny imperfections created unnecessary drag, and drag was the enemy. Perhaps the biggest surprise wasn't its appearance, but its engine, as instead of using a powerful aircraft engine costing tens of thousands of dollars, Rutan selected a modest 18-horsepower Onan two-cylinder engine, which is less power than many riding lawn mowers produced today. Yet thanks to its incredibly clean aerodynamic design, the Quickie could cruise at nearly 120 miles per hour, while burning only a fraction of the fuel consumed by conventional light aircraft. Pilots quickly realized they weren't just flying an inexpensive airplane, but were flying one of the most efficient aircraft ever built. And the Quickie also introduced many homebuilders to the world of composite aircraft construction, as before its arrival most amateur-built airplanes relied on aluminum tubing or wooden structures. The Quickie proved that fiberglass wasn't just lighter, but could also be stronger, smoother, and more aerodynamic, and its influence spread rapidly as thousands of kits were sold across the United States and around the world, with entire workshops filled with builders carefully sanding wings late into the night, determined to create the perfect finish. At gatherings hosted by the Experimental Aircraft Association, rows of brightly painted Quickies became a familiar sight, and each one reflected its builder's personality, with no two looking exactly alike, as some featured larger engines. Others had custom cockpits, and a few were modified for even greater speed, meaning every airplane told a different story. Of course, the Quickie wasn't perfect, as its unusual landing characteristics required careful training. Crosswinds demanded respect, and because of its unique design, it handled differently from conventional aircraft. So new pilots quickly learned that this wasn't an airplane you simply climbed into and mastered on the first flight, but rather it rewarded patience, precision, and good technique. Those who learned to fly it properly often fell in love with its incredible efficiency and surprisingly responsive handling. And today, nearly half a century after its first flight, the Quickie remains one of Burt Rutan's most celebrated creations, proving that innovation doesn't always require more horsepower, but sometimes simply requires better ideas. The Quickie challenged decades of conventional aircraft design and inspired an entire generation of homebuilders to think differently. But if the Quickie rewrote the rules of fixed-wing aviation, our next machine abandoned wings altogether and instead relied on a spinning rotor above the pilot's head, creating an aircraft so stable at low speeds that it became a movie star. Coming up next, with the legendary Ken Wallace WA-116 gyrocopter. Number 8 is the Ken Wallace WA-116 gyrocopter, the flying machine that outperformed expectations, as some aircraft rely on powerful engines and others depend on sophisticated electronics, but the WA-116 relied on something far simpler, which is the wind. At first glance, it looks almost unfinished, with a single seat, a steel tube frame, an exposed engine, and a giant rotor spinning overhead with no cockpit, no doors, and no windshield, just the pilot sitting in the open air. And to anyone unfamiliar with gyrocopters, it looks more like a machine built for a science fair than something capable of real flight, but appearances can be deceiving, because this tiny aircraft became one of the most successful home-built rotorcraft ever created. Behind it stood one remarkable man named Wing Commander Ken Wallace, who was a decorated Royal Air Force pilot, engineer, inventor, and lifelong aviation enthusiast who had already flown bombers during World War II. And after the war, while many pilots retired from aviation, Wallace became obsessed with one question regarding how personal flight could become simpler, safer, and more affordable. His answer wasn't another airplane, but was instead a gyrocopter, And although gyrocopters had existed since the 1920s, they were often misunderstood, as many people assumed they were just small helicopters, when in reality they work very differently because unlike a helicopter, the rotor on top isn't powered during normal flight. Instead, a rear-mounted propeller pushes the aircraft forward, and as air flows upward through the rotor, the blades begin spinning freely in a process known as autorotation, where that spinning rotor creates lift, resulting in an aircraft that's surprisingly stable, incredibly maneuverable, and far less mechanically complex than a helicopter. For Wallace, simplicity wasn't just a design philosophy but was the key to reliability, as the WA-116 eliminated hundreds of moving parts found in conventional helicopters, with no complicated transmission driving the rotor, no heavy gearbox, and no tail rotor to counter engine torque, meaning fewer parts meant fewer things that could fail, which made the aircraft lighter, easier to maintain, and far more affordable for private builders. Power came from a compact McCulloch four-cylinder engine originally developed for military target drones, producing around 72 horsepower, which gave the tiny gyrocopter more than enough thrust to cruise comfortably while using surprisingly little fuel. And despite its skeletal appearance, the WA-116 proved incredibly capable, as it could take off from remarkably short distances, land almost anywhere, and fly safely at speeds where many conventional airplanes would already be approaching a stall. That ability made it useful for far more than weekend flying, as Wallace demonstrated the aircraft in agricultural surveys, wildlife observation, aerial photography, and search missions where fixed-wing airplanes struggled with low-speed maneuvering, but the gyrocopter excelled. But its greatest moment came far from engineering workshops and came instead in Hollywood, when in 1967 the producers of the James Bond film You Only Live Twice needed a unique aircraft unlike anything audiences had ever seen, and the WA-116 was the perfect choice. Modified with mock machine guns and rocket launchers, it appeared as Little Nelly, piloted by Sean Connery's James Bond during one of the franchise's most memorable aerial sequences. And ironically, many of the most dangerous flying scenes weren't performed by actors at all, as Ken Wallace himself flew the aircraft during filming, executing the demanding maneuvers that made Little Nelly an aviation icon. The movie introduced millions of people to gyrocopters for the very first time, and interest exploded almost overnight, with builders around the world beginning to dream of constructing their own personal rotorcraft. And even into his 80s and 90s, Ken Wallace continued flying his creations, while many pilots had long since retired, as he was still demonstrating gyrocopters at airshows, proving that intelligent engineering and disciplined flying could keep these unusual machines both practical and remarkably safe. By the end of his career, Wallace had set numerous world records, designed multiple gyrocopter models, and inspired generations of homebuilders, as his machines proved that aviation doesn't always need bigger engines or more complicated technology, because sometimes the smartest solution is also the simplest. But if you think building a gyrocopter in your garage sounds ambitious, the next aircraft takes Homebuilt aviation into an entirely different era. So imagine creating a manned airplane from foam insulation boards, aluminum tubing, electric motors, and rolls of tape, then climbing inside it yourself, which most people would never even consider, but one YouTube engineer actually did. Coming up next, with the unbelievable 4 Malawian Kwaches homemade electric airplane. Number 7 is the 4 Malawian Kwaches homemade electric airplane, the YouTube airplane that shouldn't have flown but did, as building an airplane has never been easy, and for decades it required specialized tools, expensive materials, and years of aviation knowledge. But what if someone told you that a flyable aircraft could be built using materials from an ordinary hardware store, like foam insulation boards, aluminum tubing, packing tape, and electric motors? It sounds more like a school science project than a real airplane, yet that's exactly what happened, because the 4 Malawian Kwaches wasn't created by a major aerospace company or an experienced aircraft manufacturer, but was instead built by Peter Sripol, a YouTube creator known for pushing the limits of DIY engineering, whose goal wasn't to compete with certified aircraft, but was to answer a question that many engineers secretly wondered about, regarding how simple a real airplane could become and still fly safely. After several smaller prototypes and countless experiments, Sripol began designing what would become the 4 Malawian Kwaches, which, unlike traditional home-built airplanes made from aluminum or composites, relied heavily on lightweight foam board, the same material commonly used for radio-controlled model aircraft. And to most pilots, the idea sounded completely unrealistic, as foam was for toys and not for carrying a human being thousands of feet into the sky. But engineering isn't about assumptions, but is about numbers, where every gram mattered and every component had a purpose. And the lightweight airframe allowed the aircraft to use 2 powerful brushless electric motors powered by high-capacity lithium polymer batteries that together produced enough thrust to lift both the airplane and its pilot with surprising confidence. Unlike gasoline engines, electric motors deliver maximum torque instantly, So the moment the throttle moved forward, both propellers responded immediately with no vibration and no delay but only smooth silent acceleration. And watching the four Malawian Quaches take off for the first time feels almost surreal, as from a distance it looks like someone enlarged a giant RC airplane until it was just big enough to fit a person inside. The open cockpit leaves the pilot completely exposed to the wind. The landing gear was built using modified bicycle wheels, and many structural components came directly from local hardware stores. Yet even experienced aviators struggled to believe what they were seeing, but against all expectations it flew successfully, and perhaps even more impressively, it landed safely. That first flight quickly spread across YouTube, reaching millions of viewers around the world, as some praised the incredible creativity, while others questioned the risks involved. Professional engineers debated the structural integrity of foam construction, and pilots discussed redundancy, battery reliability, and emergency procedures. But regardless of opinion, one fact remained undeniable, which is that the four Malawian Quaches had accomplished exactly what its creators set out to prove: as affordable electric. Flight was no longer just an idea but was possible. Of course, the aircraft had limitations, as battery endurance was measured in minutes rather than hours. Strong winds could dramatically affect handling, and there were no sophisticated avionics, no ballistic parachute, and no luxurious cockpit, but just a lightweight frame, electric motors, and one determined builder willing to become his own test pilot. In many ways, the four Malawian Quaches represents a new generation of experimental aviation, because unlike the legendary garage builders of the 20th century, today's innovators have something their predecessors never had, which is the internet, meaning every success, every failure, and every modification can be shared instantly with millions of people, so one person's workshop becomes a global classroom where thousands of aspiring builders watch, learn, improve the design, and push the idea even further. That's what makes the four Malawian Quaches so important, as it isn't just an airplane but is proof that innovation no longer belongs only to major aerospace companies, because sometimes it begins with a camera, a garage, and someone bold enough to ask why not. But as unconventional as the four Malawian Quaches may be, the next machine blurs the line between aircraft and boat so completely that governments struggled to decide how to classify it, regarding whether it flies or floats. And the answer is a little bit of both, coming up next with the incredible Universal Hovercraft Hoverwing. Number 6 is the Universal Hovercraft Hoverwing, the aircraft that wasn't really an airplane or a boat, as what happens when an airplane and a hovercraft have a child is something that looks straight out of a science fiction movie called the Hoverwing. At first glance, it's almost impossible to classify, because it has wings, a giant propeller, a hovercraft skirt, and a hull that schemes just inches above the water, so people wonder if it is an airplane, a boat, or something in between, but surprisingly it is all three. The Hoverwing was developed by Universal Hovercraft, a company best known for building high-performance hovercraft capable of traveling over water, ice, mud, snow, and even marshland. But the company's engineers wanted to push the concept even further, and instead of simply gliding across the surface on a cushion of air, they wondered what if a hovercraft could partially fly. That single question led to one of the strangest experimental vehicles ever built, because unlike a conventional airplane, the Hoverwing never climbs thousands of feet into the sky, but instead exploits a fascinating aerodynamic phenomenon known as ground effect, where when an aircraft flies extremely close to the surface, air becomes trapped beneath the wings, creating additional lift while dramatically reducing drag. In simple terms, the closer it flies to the ground or the water, the more efficiently it flies. And while most airplanes experience ground effect for only a few seconds during takeoff and landing, the Hoverwing was designed to stay inside that invisible cushion almost all the time. Its powerful engine drives two separate systems simultaneously, as one fan pumps air beneath the flexible skirt, allowing the craft to hover just above the surface, while at the same time a large rear-mounted propeller pushes the vehicle forward. And as speed increases, the wings begin generating lift until eventually much of the vehicle's weight shifts from the hovercraft cushion to the wings themselves. The result is something unlike any traditional aircraft, because instead of bouncing across waves like a boat or climbing high into the sky like an airplane, the Hoverwing glides smoothly just a few feet above the water at impressive speed. And to the pilot, it feels almost surreal, as you are flying but never truly leaving the surface behind. One of the biggest advantages of this design is versatility, as rough water that would slow many boats becomes much less of a problem, and it can cross shallow rivers, frozen lakes, snow-covered terrain, and wide marshlands that challenge both boats and airplanes alike without needing a runway, deep water, or even a prepared launch site. That flexibility has attracted adventurers, rescue organizations, and experimental aviation enthusiasts from around the world. But operating such an unusual machine isn't without risks, because ground effect is incredibly efficient, but can also be unforgiving, as a sudden gust of wind, A sharp control input or an unexpected obstacle can quickly upset the delicate balance that keeps the aircraft stable. Unlike conventional airplanes, the hover wing has very little altitude available for recovery since everything happens just a few feet above the surface with almost no room for mistakes, which is why experienced pilots describe flying it as a constant exercise in precision. One of the most interesting aspects of the hover wing isn't mechanical at all but is legal because the vehicle typically operates within ground effect and rarely performs conventional flight, causing aviation authorities in different countries to struggle to decide exactly how it should be classified as an aircraft, a marine vessel, or an entirely new category of transportation depending on where it's being operated. That legal gray area has made the hover wing one of the most fascinating experimental vehicles ever created, as it challenges not only engineering but the very definitions of flight itself. And even today, the concept continues to inspire designers searching for faster, more efficient ways to travel over water without the cost and complexity of traditional aircraft. The hover wing reminds us that innovation doesn't always mean flying higher, because sometimes the biggest breakthrough comes from flying lower, much lower. But if gliding just above the water seems daring, our next machine does something even more unbelievable. So forget wings, forget runways, and forget even sitting inside an aircraft, as you should imagine strapping yourself beneath 4 screaming 2-stroke engines, then lifting straight into the sky in what looks like a mechanical backpack. It sounds impossible, but one Japanese engineer turned that dream into reality. Coming up next with the incredible Gen H-4, which is the world's smallest coaxial helicopter. Number 5 is the Gen H-4, the world's smallest helicopter. As for decades, inventors dreamed of creating the ultimate personal aircraft that was small enough to fit in a garage, simple enough to transport in the back of a truck, and capable of taking off vertically from almost anywhere. But most people believed it was impossible because helicopters were simply too complicated, too expensive, and too dangerous. Then one man in Japan decided to prove everyone wrong, and his name was Junai Yanagisawa, who, unlike major aerospace companies with unlimited budgets, worked with a single vision to build a helicopter that anyone could own. And the result was unlike anything the aviation world had ever seen, called the Gen H-4. At first glance, it doesn't even look like a helicopter, as there is no enclosed cockpit, no sleek fuselage, and no luxurious instrument panel, but instead the pilot sits in what resembles a lightweight racing seat surrounded by an exposed aluminum frame with 2 enormous coaxial rotor systems spinning above their head and almost nothing below them, making it look less like an aircraft and more like someone strapped a lawn chair beneath a pair of giant spinning blades. Yet this extraordinary machine earned a place in aviation history, as the Gen H-4 holds the Guinness World Record as one of the smallest manned helicopters ever built, and despite its tiny size, it is a fully functional aircraft. What makes the Gen H-4 truly fascinating isn't just its appearance, but is the engineering hidden beneath its minimalist design, because traditional helicopters rely on a single main rotor and a tail rotor to counteract torque, which works well, but is mechanically complex. Whereas Yanagisawa chose a completely different approach, where the Gen H-4 uses 2 counter-rotating rotors mounted one above the other. Because the rotors spin in opposite directions, they naturally cancel each other's torque, meaning there is no tail rotor, no long drive shaft, and far fewer moving parts, so the entire aircraft becomes lighter, simpler, and easier to maintain. Power comes from an even more surprising source, as instead of one large engine, the Gen H-4 uses 4 compact 2-stroke engines, each producing approximately 10 horsepower, which together generate around 40 horsepower. And while that may not sound impressive, it is more than enough for an aircraft weighing only around 70 kilograms without the pilot. There is another reason Yanagisawa chose 4 engines, which is safety, because if one engine loses power, the remaining 3 continue driving the rotor system, giving the pilot precious seconds to make a controlled landing, serving as a clever example of redundancy without adding unnecessary weight. Flying the Gen H-4, however, is an experience unlike almost anything else, as the pilot sits completely exposed beneath 2 spinning rotors turning at hundreds of revolutions per minute, with no doors, no windshield, and no protective cabin, but only open sky in every direction, where every gust of wind can be felt immediately and every movement of the controls produces an instant response. It is exhilarating, but also demands absolute concentration, because unlike larger helicopters that naturally dampen pilot inputs, the Gen H-4 is incredibly responsive, so small corrections are essential, as overcorrecting causes the aircraft to respond immediately, meaning mastering the Gen H-4 requires patience, discipline, and a deep understanding of rotorcraft flying. Yet despite its unusual appearance, the little helicopter proved itself remarkably capable, as it demonstrated stable hovering, smooth vertical takeoffs, and controlled landings that impressed engineers around the world. and the project quickly became a symbol of Japanese innovation, showing what could be achieved through intelligent engineering and relentless simplification rather than building something larger and more powerful. Although the Gen H-4 never entered mass production, its influence continues to inspire designers developing compact personal aircraft today, and in many ways it was decades ahead of its time because long before electric air taxis and personal eVTOL aircraft became headline news, the Gen H-4 had already shown that personal vertical flight was possible. It may have looked fragile, but it proved that extraordinary ideas don't always come from billion-dollar companies, as sometimes they come from a small workshop and one engineer who refuses to believe something can't be done. But if the Gen H-4 represents the past of personal vertical flight, our next machine may represent its future. So imagine climbing into what looks like a luxury cabin hanging beneath a giant drone with no runway and no pilot but just electric motors, advanced software, and a flight computer making thousands of decisions every second. Welcome to the future of aviation, coming up next with the revolutionary Aeronext Flying Gondola. Number 4 is the Aeronext Flying Gondola, the eVTOL that wants to reinvent flight. As for more than 100 years, every aircraft has shared one unavoidable problem, which is that whenever it turns, the cabin tilts, causing passengers to feel it, coffee to spill, and stomachs to churn, so that for many people motion sickness becomes part of the journey. Now imagine an aircraft that can bank sharply into a turn while the cabin stays almost perfectly level, which sounds impossible, but that's exactly what engineers at Aeronext, a Japanese aerospace company, are trying to achieve, because unlike the garage-built aircraft seen previously, the flying gondola represents a new generation of experimental aviation where instead of asking how to build a cheaper airplane, its designers asked a completely different question regarding how to make flying feel as comfortable as riding an elevator. The answer became one of the most unusual aircraft concepts ever designed, because at first glance the flying gondola doesn't even resemble an airplane, as there is no cockpit, no wings stretching across the sky, and no spinning propeller at the nose, but instead the passenger cabin hangs beneath a large electric multi-rotor platform, almost like a modern ski lift gondola suspended from an invisible crane. But the real innovation isn't what you can see, but is what happens while the aircraft is moving, because traditional helicopters, airplanes, and even today's drones tilt their entire body to change direction, whereas the flying gondola does something completely different, as its passenger cabin is mechanically isolated from the propulsion system. As the upper frame leans into a turn, the cabin remains remarkably stable, reducing the sensation of banking and helping passengers feel more comfortable throughout the flight. And Aeronext calls this concept 4D gravity, which uses a combination of advanced mechanics, sensors, and intelligent flight control software, so the aircraft constantly shifts and balances its center of gravity with hundreds of tiny adjustments happening every second that most passengers would never even notice, because to them the ride simply feels smooth. Power comes from multiple electric motors positioned around the upper frame, and unlike conventional aircraft that rely on a single engine, the flying gondola uses distributed propulsion, meaning if one motor experiences a problem, the remaining motors can help maintain controlled flight, which is a level of redundancy that's becoming increasingly common in modern eVTOL aircraft. Of course, building such a machine is far from easy, as keeping a suspended cabin perfectly stable while the aircraft accelerates, climbs, descends, and turns requires enormous computing power, where every sensor, every motor, and every flight computer must communicate almost instantly, because a delay of even a fraction of a second could affect stability, which is why the flying gondola depends on software just as much as hardware, and in many ways is closer to a flying computer than a traditional aircraft. Today, prototypes continue to undergo testing as engineers refine the technology, and the goal isn't to replace commercial airliners, but is to transform short-distance transportation. So imagine crossing a crowded city in 10 minutes instead of spending an hour stuck in traffic. Imagine emergency medical teams reaching remote locations without waiting for a runway, or imagine daily commuting through the sky, as that's the future Aeronext hopes to build. Whether that future arrives in 5 years or 20 remains to be seen, but one thing is already clear, which is that the next revolution in aviation won't necessarily come from faster airplanes, but may come from making flight feel so natural that passengers forget they're even flying. And the flying gondola reminds us that innovation isn't always about speed, because sometimes it's about changing the entire experience. But while engineers in Japan are building aircraft designed to make passengers more comfortable, one team asked a far more dangerous question regarding what if the pilot didn't sit inside the aircraft at all, with no cockpit, no doors, and no seat, but just a person standing on top of a giant drone. Which sounds like science fiction, yet someone actually built it and flew it. Coming up next with the Dragon Airboard. Number 3 is the Dragon Airboard, the flying platform that turned a human into the landing gear. As imagine standing on a platform no larger than a coffee table with nothing around you, no cockpit, No seatbelt and no windshield but just open air while beneath your feet 8 high-powered propellers spin at thousands of revolutions per minute where one wrong movement or one mechanical failure means there's nothing between you and the ground. It sounds less like an aircraft and more like a dare, yet that's exactly what the Dragon Airboard became as it was built for the Goffley Prize, a global competition sponsored by Boeing where the project challenged engineers from around the world to answer a question that had fascinated inventors for decades regarding whether one person could fly using a machine small enough to fit in a garage. Teams from dozens of countries entered the competition, with some designing miniature helicopters and others building jet-powered backpacks. But the Dragon Airboard team chose a completely different approach where instead of putting the pilot inside the aircraft, they made the pilot part of the aircraft, resulting in something that looked straight out of a futuristic action movie featuring a lightweight carbon fiber platform, multiple electric motors arranged in perfect symmetry, a handheld control stick, and a pilot standing upright above the rotors balancing as if surfing through the sky. There were no wings, no cockpit, and no traditional flight controls, but just software, physics, and trust, because unlike a conventional helicopter where the pilot manually controls nearly every aspect of flight, the Dragon Airboard depends heavily on advanced flight computers, as every second onboard processors analyze thousands of pieces of data from gyroscopes, accelerometers, GPS receivers, and electronic sensors. Those computers make hundreds of tiny corrections every single second, and without them the aircraft would become uncontrollable almost instantly, meaning in many ways the pilot isn't directly flying the machine but is giving commands while the computers do the impossible work of keeping everything balanced using the same technology that allows modern drones to hover perfectly still in the air, only this time the drone is carrying a human being. Power comes from an array of high-performance electric motors driving oversized carbon fiber propellers that together generate hundreds of pounds of thrust instantly, and electric propulsion gives the Dragon Airboard one major advantage over gasoline-powered aircraft because the moment the pilot moves the throttle, every motor responds almost immediately with no engine lag and no complicated transmission but only smooth, precise power. Of course, building such a machine required solving an enormous engineering challenge, as the pilot stands above the center of thrust, which creates an inherently unstable design where even a slight shift in body weight changes the aircraft's balance. So to compensate, the flight control system constantly adjusts the speed of each motor independently, with tiny corrections happening so quickly that they're invisible to the human eye, yet they're the only reason the aircraft remains stable. Watching the Dragon Airboard fly is unforgettable as the pilot appears to float effortlessly above the ground, almost like a superhero, but behind that graceful motion lies an extraordinary amount of computing power, because unlike the pioneers of the 1950s, today's engineers aren't relying solely on clever mechanical design, but are combining aerospace engineering with artificial intelligence, real-time software, and advanced electronics, so the result feels like a glimpse into the future. Although the Dragon Airboard was created as part of an engineering competition, rather than a commercial product, its technology attracted serious attention as emergency responders saw potential for rapid deployment in difficult terrain. Military researchers explored possible reconnaissance applications, and even search and rescue teams imagined reaching locations where helicopters couldn't safely land. And whether those ideas become reality remains uncertain, but the Dragon Airboard proved something remarkable, which is that personal flight is no longer limited by engines alone, but is increasingly defined by software. So as computers continue to evolve, machines like this may become far more common than anyone expects. Still, as futuristic as the Dragon Airboard looks, the next aircraft on our list throws technology out the window with no aerodynamic body, no sleek carbon shell, and no elegant engineering, but just one ordinary household object that absolutely no one expected to see flying. So imagine walking outside, looking up, and watching a bathtub cruising through the sky, which sounds like a joke until you realize someone actually built it. Coming up next with the unforgettable flying bathtub. Number 2 is the flying bathtub, the craziest aircraft ever built in a backyard. As if someone told you they flew to the bakery in a bathtub, you'd probably think they were joking, because after all, bathtubs belong in bathrooms and not thousands of feet above the ground. But for a group of German inventors known as the real-life guys, even the most ridiculous ideas deserved a chance to fly, with a simple motto that if it sounds impossible, let's build it anyway. Over the years, they transformed everyday objects into outrageous engineering projects, including flying bicycles, rocket-powered machines, and custom-built inventions that looked more like movie props than real vehicles. But none of their creations captured the world's imagination quite like the flying bathtub, which began as a joke between friends when someone asked, could a bathtub actually fly? And while most people laughed, the team started drawing blueprints. The first challenge wasn't aerodynamics but was weight, because a traditional cast-iron bathtub would be far too heavy to lift, so instead they selected a much lighter fiberglass tub. and built a custom steel frame around it where every component had to be carefully reinforced since the bathtub itself had never been designed to handle the forces of flight as it wasn't built to support motors, absorb vibration, or carry a pilot through the air, making the engineering challenge enormous. To generate enough lift, the builders mounted 6 high-powered electric motors, each fitted with oversized carbon fiber propellers that together produced enough thrust to lift both the aircraft and its pilot vertically. And instead of traditional flight controls, the flying bathtub relied on sophisticated flight control electronics similar to those found in professional heavy-lift drones, where the onboard computer constantly adjusted the speed of each motor, making hundreds of corrections every second to keep the aircraft balanced, because without that software the bathtub would have flipped over almost immediately. Watching the flying bathtub take off for the first time is almost surreal as the pilot climbs into what appears to be an ordinary bathtub wearing a flight helmet while otherwise everything looks completely absurd. Then the motors begin to spin, the sound grows louder, dust swirls beneath the aircraft, and before your brain has time to process what's happening, a bathtub slowly rises into the sky, causing people watching from the ground to laugh because it looks like a scene from a comedy film. But behind the humor is real engineering, as every bolt, every battery, every electronic controller, and every structural weld had to work perfectly, because unlike a certified aircraft, there were very few backup systems, and a serious failure at low altitude could have ended the flight in seconds, which is why every test was carefully planned and conducted in controlled conditions. The project quickly went viral as millions of people watched the videos online, and news outlets around the world shared the story, turning what started as a playful experiment into one of the internet's most famous homemade flying machines. And perhaps the funniest moment came during one demonstration when, instead of simply flying around a field, the team decided to make the flight look completely normal, so the pilot calmly lifted off, flew across town, and landed outside a local bakery to pick up food. The image of a man arriving in a flying bathtub as if it were an everyday vehicle instantly became internet legend, and while it was funny and bizarre, it also carried an important message that innovation doesn't always begin with complicated equations, but sometimes begins with curiosity, creativity, and people willing to ask questions everyone else dismisses as ridiculous. The flying bathtub will probably never become the future of transportation, and wasn't designed to, as its purpose was something far more valuable, which is to remind us that engineering can still be playful, that imagination still matters, and that sometimes the craziest ideas inspire the biggest conversations. Yet, unbelievable as a flying bathtub may seem, it still isn't the most astonishing aircraft ever built, because the #1 machine on our list wasn't designed to make people laugh but was built to break a world record as an airplane so incredibly small that many experienced pilots believed it simply couldn't fly, and yet it did. Coming up next with the legendary Stitz SA-2A Skybaby, which is the smallest manned monoplane ever built. Number 1 is the Stitz SA-2A Skybaby, the smallest airplane that ever conquered the sky, as throughout aviation history engineers have chased one impossible dream, with some wanting to build the fastest airplane, others wanting the highest, the lightest, or the most efficient. But in the early 1950s, one American designer had a completely different ambition, which was to build the smallest flyable airplane on Earth that was not a model or a toy but a real aircraft capable of carrying a pilot into the sky. Most experts believed it couldn't be done because as an airplane becomes smaller, it also becomes dramatically more difficult to control, since tiny wings produce less lift, control surfaces become increasingly sensitive, and even small gusts of wind can have a huge effect on stability until eventually physics wins, or at least that's what everyone thought. But aircraft designer Ray Stitz wasn't interested in what people thought was impossible and wanted to discover where the true limit really was. While working in a modest workshop in California to design what would become one of the most legendary experimental aircraft ever built, called the SA-2A Skybaby. When completed in 1952, the airplane looked almost unreal, as its wingspan measured just 7 feet 2 inches, or about 2.18 meters, which, to put into perspective, means many modern SUVs are actually wider than the Skybaby's wings, so standing next to it feels almost surreal, because instead of climbing into the cockpit, it looks as if you're putting the airplane on. Despite its tiny dimensions, the Skybaby wasn't light, and far from it, as the compact airframe demanded an unusually powerful engine to generate enough airflow over its tiny wings, so Ray Stitz selected a Continental C-85 four-cylinder aircraft engine, producing around 85 horsepower, which after extensive modifications and careful tuning delivered even greater performance. That enormous amount of power, combined with the aircraft's incredibly short wings, created one of the most demanding flying machines ever built, where takeoff required absolute precision and landing demanded complete concentration with almost no margin for error, because the aircraft's stall speed approached 80 miles per hour, meaning it had to remain surprisingly fast even during landing, as slowing down too much would cause the wings to simply stopped producing enough lift. Pilots who watched the Sky Baby perform often described it as looking more like a rocket than an airplane, and once airborne, every control input had to be delicate, as a movement of only a few centimeters could produce an immediate response, with former test pilot Robert "Bob" Starr, who was one of the few people qualified to fly the aircraft, later explaining that the Sky Baby required constant attention with never a moment to relax, and every second in the cockpit demanding total focus. Yet despite its intimidating characteristics, the Sky Baby flew beautifully in the hands of an experienced pilot, and at air shows across America crowds watched in disbelief as the world's smallest airplane roared overhead, causing people to point toward the sky wondering whether they were looking at a real aircraft or some elaborate illusion. But it wasn't just a publicity stunt, as it was proof that careful engineering could stretch the limits of aviation farther than anyone believed possible. The Sky Baby officially held the title of the world's smallest manned airplane for several years, becoming one of the most famous experimental aircraft ever built. And even today, more than 70 years later, it remains an icon of aviation history, whose influence extends far beyond its size, as it represents something much bigger, including the courage to challenge accepted limits, the willingness to risk failure in pursuit of innovation, and the belief that impossible ideas deserve to be tested, rather than dismissed. Today, the original Sky Baby is preserved in a museum where visitors often stop in disbelief, and many ask the same question regarding whether someone really flew this, and the answer is yes, which is exactly why it deserves the #1 spot on this list. Looking back at these incredible machines, one thing becomes clear, which is that none of them were created by accident, as behind every unusual aircraft was a dream, a challenge, and a problem that someone refused to accept as impossible, because some builders wanted to make flying cheaper while others wanted to make it smaller, safer, faster, or simply more fun. And while many of these aircraft looked strange, every single one expanded the boundaries of aviation in its own unique way. They remind us that innovation doesn't always begin inside billion-dollar laboratories, but sometimes starts in a garage, a small workshop, or even a backyard with a handful of tools, a sketch on a piece of paper, and someone brave enough to ask what if. So now it's your turn to tell us which aircraft surprised you the most, whether it was the tiny Cricri, the legendary Quickie, the Hollywood-famous Little Nelly, the futuristic flying gondola, or perhaps the unforgettable flying bathtub. By letting us know in the comments below. If you enjoyed this countdown and want to see more incredible stories from the world of aviation, engineering, and impossible inventions, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next adventure, because somewhere in a garage or workshop someone is already building the next aircraft the world will swear can never fly until it does.